Look at Earth from space, and there's no sign of life. Our beautiful planet is just that, a symphony of colour and form. Some colour is false to enhance geological features. But where are we? Look closer, and there are the works of humankind. The city of Boston, with its airport and harbour on the northeast coast of America. But climb higher, and we disappear. From here, who would know Earth is home to 6 billion human beings? It may be planet Earth, but 2/3 of the surface is water. Compare this seascape with the barren terrain of neighbouring worlds. Our oceans teem with life. Simple organisms probably first appeared here. Eons later, evolving lungs and limbs, life crawled ashore. Today it populates 6 continents, with one species evolving to dominate: Homo sapiens. In the 11,000 years since the last ice age, we've developed agriculture. Allowing few to feed many, it's the basis of civilization, freeing others to be artists, teachers, scientists. Not only has farming changed the landscape, but cities have too. Here's Chicago spewing pollution into Lake Michigan. As no other species, we've changed the environment and eagerly burnt non-renewable resources. Rotating once a day, Earth takes a year to orbit the Sun at a distance of 150 million kilometers. Earth is the largest inner planet, 3rd from the Sun and 1st with the Moon. Little more than a veneer, the top layer of Earth is the crust. It's thickest beneath the continents, as much as 80 kilometers, but thins to 10 under the oceans. Below is the hot mantle, a mix of partially melted and solid rock. Then comes the liquid outer core, and within, the solid inner core, a slowly rotating heart of iron and nickel. This rotation inside the molten outer core is thought to be the dynamo generating our magnetic field. In the northern hemisphere, magnetic north is really a south pole. It attracts the north pole of a magnet in a compass, but not always. Every few 100,000 years, the poles reverse, and no one knows why. Volcanic eruptions are symptoms of Earth's hot interior. Through vents in the crust, lava releases heat lost from the core as it slowly solidifies. Earth's crust is like a cracked eggshell. The cracks are boundaries of great plates, and where plates interact, there are earthquakes and volcanoes. But the greatest consequence is continental drift. Riding on partially melted strata in the upper mantle, this is how plate movement has changed the map of Earth during the past 500 million years. As plates crashed together, mountain ranges grew, like the Alps, where Italy hit Europe, and the Himalayas, where the Indian subcontinent collided with Asia. And where plates have pulled apart, huge fissures appeared, as here in the Dead Sea Rift Valley. Earthquakes and volcanoes mean plates are either pulling or pushing. They move at between 1 and 10 centimeters a year. And the process continues, whether in the oceans or from billowing peaks. Of the 4 inner planets in the solar system, Earth spins fastest, a rotation that gives us night and day. It means the Sun appears to move across the sky. But the Sun's not moving. Earth is turning on its axis. A 24-hour cycle that affects our weather, as the changing angle of the Sun heats us and cools us. If our planet had an upright axis, the length of day and night would always be the same, whether at the equator or north and south of the tropics. But Earth is tilted at 23 degrees. That means day and night vary through the year. As we orbit the Sun, the angle at which sunlight strikes us changes a little day by day, and it causes the seasons. Here, as the northern hemisphere tilts away from the Sun, it's winter. Days are short, nights are long. 6 months later, when the north tilts towards the Sun, it's summer. Days are long, nights are short. The reverse is the case in the southern hemisphere. Most of our weather patterns depend on a simple fact. Hot air rises. And it's the Sun that drives those patterns. As it heats the oceans, evaporation occurs. Air laden with water vapor rises. And as it cools higher in the atmosphere, clouds form. Rising air, where there's cloud, causes low pressure. Falling air, where it's clear, causes high pressure. Air at high pressure always moves towards low pressure. This creates the winds that blow around our planet. About the equator, where heat from the Sun is greatest, masses of cloud, heavy with vapor, form high in the atmosphere. Here they're pictured from space. Thunderstorms and torrential rain pervade the tropics and nurture the equatorial rainforests. Driven by the intensity of the Sun, larger storms whirl from the tropics, cyclones, typhoons, and this, a hurricane off the United States. On land, there can be dreadful damage. Global weather works like this. At the equator, where the Sun is intense and air rises, pressure is low. At the poles, where the Sun's rays are weak and air falls, pressure is high. Between the two, in the northern hemisphere, air falls just north of the tropics, but it rises farther north in the moist temperate regions. This creates 3 engines of circulating air. The effect over Africa is lush forest at the cloudy equator and desert in the clear Sahara. Europe is cloudy and damp. Here, a dust storm has blown into the Atlantic. To the right, the vast Sahara straddles this arid high-pressure zone. In Europe, cloud scuds from the ocean. The Atlantic seaboard is especially wet. It's changeable in this normally low-pressure zone. But in high-pressure polar regions, it's relatively cold and dry. The Sun isn't at a constant distance from Earth. Our near-circular orbit is sometimes more elliptical, but the change is slow, a cycle of some 400,000 years. This effect, however, a wobble of our axial tilt, occurs over 26,000 years. And this one, a change in tilt from 22 to 24.5 degrees, happens during a cycle of 41,000 years. Many scientists believe these effects contribute to ice ages. The last one ended just 11,000 years ago, after a grip of 90,000 years. It's no Hollywood fantasy that Earth will suffer another ice age. For our grasp on this world is tenuous. Our cities, our crop growing, are but scratches on a fragile planet. Earth is a lucky place. We have air to breathe because green plants evolved to produce oxygen. They emerged thanks to water and Earth's fortuitous distance from the Sun. This wonderful planet is precious and, in cosmic terms, precarious.